we're going to do here today. My name is Brett Kisker, and I am the Executive Director of the Northland CAPS organization. I'm also a member of the Northland Education and Business Alliance, or NEBA. And NEBA is a network of education and business organizations here in Clay and Platte counties in Missouri, whose vision is to promote and provide business-driven educational opportunities for you, because you, our students at home right now, you're our next generation of business leaders, and we want you to understand the opportunities that exist here. I'm going to be your host during this session, but we actually have two really other important people in the room with me working in the background. The first one is Adam Jelinek, who you can see on the screen. Adam works for Magna LMV in Liberty, Missouri, as a director of HR there, and he's going to be helping with Q&A. And we also have Julie Lewis, who is with the Clay County Economic Development Council, and she's helping with things behind the scenes. Just a few quick notes before we introduce our guest speakers, our very important guest speakers here today. This session is going to run for about 40 minutes. We have a hard stop at 11:40 because we have other sessions following behind. And our industry experts here are going to begin by sharing the professional history and insight, but we want this to feel more like a conversation. So at the bottom of your screen, if you look down at the bottom, you're going to see an option to use the Q&A feature. So with that Q&A, we encourage you to use that space to post any questions you might have for the guest speakers at any point in time during this session. We might not be able to get to them all, but we're going to do our best. And when this session ends, you'll be asked to take a very short survey. We want you to give some feedback on this event so we get better at things hosting, like this in the future. And last but not least, just understand that when you walk away, this session will be recorded and available online in the near future on our YouTube page. So with that in mind, let's get started. I would like to go ahead and introduce to you our two very important people that we have brought in from the industry to talk about careers in engineering. The first one is Bridget Gray, and the other is Rachel Henkhaus. And so, Bridget, if you would like to go ahead and introduce yourself and talk about your professional history, we'll get going.
Sure, thanks, Brett. As you mentioned, my name is Bridget Gray, and I am an assistant engineer for Olsson, which is located in North Kansas City. I graduated in 2018 from Rockhurst University here in Kansas City with a civil engineering degree. And what's neat about that, a lot of people may not know that Rockhurst has an engineering program, but it's really new, and I'm actually working with some of our professors to get Rockhurst ABET accredited. So that's pretty cool. I was one of the first 5 women to graduate from the program, and that's kind of my claim to fame at Rockhurst. But I have worked at Olsson since I graduated, so about 2.5 years. And I also did a couple of internships, which, if you are thinking about engineering, are really crucial to seeing what's out there, to seeing what you may be interested in specializing in, and just to see the day-to-day of it. I interned on the public sector with the Missouri Department of Transportation in Lee Summit. And I also interned in Kansas City at HNTV, which is another engineering consulting firm like Olsson. My primary focus in my career is water and wastewater engineering. So if you think about everything from the water in your tap, how does it get there? How does it come out of your faucet to your wastewater? I do all the behind the scenes infrastructure work to make sure we have clean water distribution and treatment, as well as wastewater collection and treatment. So that's a little bit about me. So with that, I'll pass it off to Rachel.
Good morning, everyone. So I'm Rachel Henkhaus. I grew up in the Kansas City area. I went to Shawnee Mission East. And at Shawnee Mission East, I had the opportunity to do architecture classes, so drafting classes. And the idea of kind of how people move into space is kind of what started my idea of where I wanted to take my career. And to be honest, so I am a bridge engineer, so kind of think about that as I talk through my story. I never expected that I would be a bridge engineer someday. So I just kept following my opportunities, and which I encourage everyone to do. You never know when you will like an opportunity, or when you figure out that, hey, this opportunity is not what I really want to do for the rest of my life. So then you always have an opportunity to find a different one. So that's in high school is where my interest started. And I wanted to do architecture in college, and I visited KU and talked to the dean of architecture, and she's like, well, do you like math? And I love math. And she's like, you should try architectural engineering. So that's how I got into engineering. I went to KU for architectural engineering as I went through my program where I had studios, but then I was also taking engineering classes. I decided I really liked the engineering part of everything. And then as I was graduating, I had this idea of, okay, I am gonna do structural engineering for buildings. And then the economy tanked, like no job opportunities. Previous years, all my classmates were having like 10 job opportunities, and people were lucky to get just one. So then the idea for me was to go on to do grad school. So I also had the opportunity at KU to do an undergraduate research assistantship. So I was doing lab work, looking at testing of different, well, I had my own little research project that tested pipes. So that took me to going to Purdue and doing research there. And I did research on concrete and looking at epoxy coated rebar in concrete and like the development of that rebar in like a splice in concrete. So that's what I went on and studied for 6 more years and got a PhD. But really how that all happened was because of what was happening with the economy. So when I was ready to graduate from that, the economy tanked again. This is kind of like a pattern for me. And I could not get an opportunity to do structural engineering for buildings, which is what I really wanted to do. But I had an opportunity to get into bridges and design bridges as my first internship. So I took that opportunity. I was very hesitant to do it, but I did it anyway, and I love it. And I've been in it for 12 years and I haven't looked back. There have been opportunities to make that switch. So I've been with Garver for almost 7 years now. And there, at that point of coming on to Garver, I had, okay. I forget if I said I was at Purdue doing my grad research. And then I worked in Indianapolis. That company I ended up continuing to work with down in Dallas, Texas. And then I ended up finding opportunities in Kansas City. And in that transition of finding opportunities in Kansas City, I had the moment to make the decision, do I stick with bridges? Do I go to structural building design? But I just really like the bridge engineering environment. I love the idea that what I do impacts everyone on a daily basis on their commutes. And that's not something I really thought of when I was younger, how what I design affects everyone on a daily basis. So with that, I'll open it up to questions.
Yeah, that's wonderful. Thank you for the introductions. And again, to the people in the audience, we have the Q&A period or the button at the bottom. And we want you to post questions there. Ask the things that are on your mind. The only question that's out of bounds is how much money do you make? And I will just tell you this. If you go into engineering, you're going to be able to put food on your plate. You're going to be just fine. Okay. All kinds of opportunities there. And I think it's really awesome, by the way, that I didn't really stress this, but both of the companies that we're talking about here are here in the Northland. It's here in Clay and Platte counties is where we exist. So you don't have to move away to have job opportunities in this kind of career field. So let me just start off with a quick question before the Q&A starts hopping here. What do you think some of the, like, when people think about engineers, they think about like mathematics and calculations and modeling and things like that, or the types of epoxy that might go on rebar, right? And what would you say that maybe is one of the misconceptions that people have about the career field of engineering that they should know about?
I'll start. So I hadn't really talked about what drew me to engineering, but I really didn't have much of an introduction to engineering in high school. I did take a AP Calc 1 class, and I really liked that. I just really liked math, but I was really a stronger like fine arts, or like, I guess not fine arts, but like writing, reading, like that was really what I was really good at it. My ACT scores would not reflect that I'm an engineer. So don't ever feel bad that you're not strong enough in math or science to be an engineer. You know, those are skills that you just have to practice. So I would stress that first and foremost, that you can work on those skills, but some skills that are a little bit harder to work on that are crucial to engineering are being able to communicate with people and being able to write and convey a complex subject into words that a layman or your average person can understand. And that is something that I'm asked to do on a daily basis. You need to take this really complex hydraulics, hydrology issue that you're seeing, and you need to be able to explain that to someone on a very high level. You have to be able to work in a team. This is not something where you just get to hide behind your desk all the time and you just crank through calculations. That is important, and it's important to understand the math, the science, and the theory behind what we do as engineers, but really communication is so important to what I do every day.
I agree. And I always wanted to just work by myself. I wanted to do my calculations and work by myself, but engineering is such a team atmosphere. And even in the process that we design things, there's a quality control aspect to it. So everything that you do is done by at least two people. So two people's eyes on everything. One person does the calculations, another person checks those calculations, and you kind of go back and forth until you are all certain that everything is safe. Also, the idea that, so engineers take an oath that's very similar to the oath that a doctor in the medical profession takes. So we protect the health, safety, and welfare of the general public. We do that with the infrastructure that's all around us, in the same way that doctors take care of what is on the inside of our bodies. We take good care of everything else that's around us. So I think that's an interesting concept.
So we do have a question in the chat, and the question is, do you travel as an engineer?
Yeah, so I do a little bit of traveling. I think it depends on what projects you're working on. Also, how your company's set up. So much is going virtual that it's starting to reduce the need for travel. Like, I know my husband's an engineer and he travels a lot more because he has to physically be there to analyze his projects, but a lot of what I do can be done in the office. So like my company has a meeting, an all company meeting that once a year there is travel by a big portion of the company for that. And then also for projects, I do a lot of local projects now, but if your projects are more nationwide, then that would require more projects or more travel for those projects.
Yeah, I'd echo what Rachel said as well. I travel probably once a month, and most of my travel is within a day. So I don't have to sleep over in a different city or get on a plane. I can drive there. But a lot of the times for me, that travel would take place at the kickoff of the project, or maybe when we have submitted a deliverable to our client and they want to go through it. So we'll go out there, meet with them, sit down with them, talk through the project and our design, and then we might go out to the site and have a look at the site. And I really enjoy doing those little site visits because it's amazing what you'll notice about a project site that you can't see on Google Maps or you can't see on your computer. But a lot of my projects are maybe an existing sanitary lift station that we have to rebuild. And so it is kind of like we have an existing site and those parameters. And so getting out there really does help. But the farthest away I've ever traveled is Manhattan, Kansas, which is about 2 hours away. So, but it really does depend on what projects you're working on and how your company is set up, how far you have to travel.
And I'll add on a little bit as far as a bridge perspective. So we have field checks and where we go out and we look at the existing site. And a lot of what we do with bridges is if there's an existing bridge, we're making the decision whether we're rehabbing that. So like whether we're taking off the deck and there's still the beams and we place a new deck, or if we're widening it, or if we're completely tearing that existing bridge down and replacing it. So we call that a replacement bridge project. There's very few times that we have like new bridge projects where there you go out and there's like nothing there. So I would say 95% of the time we're working with an existing bridge site.
But it's not just all about sitting behind a desk.
No. There's a lot you learn from being out on a site. You have to know what's out there, as Rachel said, to be able to make a decision of what are we doing here.
So in your opinion, what is the most important thing about engineering?
I would say safety. So safety of an existing bridge, safety in your design. It is amazing, like when we're looking at existing bridges and making decisions as to rehabbing or not, how there has, for whatever reason, the existing bridge didn't even meet the standards at the time it was built. And whether it was some sort of mistake. Luckily, there's a lot of like safety factors built into our design that does cover it. But of course, we don't want to ever make those mistakes that affect the safety of the public.
Yeah, I'm sitting here trying to think of a better one, and it's tough. Yeah, I'd say safety and maybe resiliency of for a water system. You know, what do we need to do to make sure that people can get water? Because it's really crucial. You can't have a water treatment plant down for any length of time. You can't have a wastewater plant down for any length of time. And you have to have backups to make sure that you're protecting water quality and you're protecting public health, to make sure that, you know, you don't have a Flint, Michigan, where something that happened is causing detrimental effects to the population for years to come.
Next question that we have in chat is, does it help if you take an engineering class in high school?
I never did, and I'm still here, but I think if you have that opportunity, it can help you make the decision of whether or not engineering is something that you're interested in. And I think the ideas that engineering teaches you, you can use in any field. So there are a lot of things, a lot of ways of thinking that engineers have that you can really take into business or teaching. You know, it's not just one thing. It's really a broad set of ideas.
What kind of degree is needed to be an engineer?
So for structural engineers, a lot of times we do need a master's. Now, I do know that there are some bridge engineers out there that are older and didn't need a master's at the time, but today, to be a structural engineer, you need a master's, but that is not the case for all civil fields. So I'll let Bridget talk more.
Yeah, so I just have my bachelor's degree in civil engineering, and I have people I work with who have degrees in environmental engineering. We have others in my company that have mechanical engineering bachelor's degrees, electrical, architectural engineering, and some of them have master's in business administration, so a business master's, and some of them have a technical engineering master's, but at this point, it's definitely not required. But for most engineering that Rachel and I do that's infrastructure related, you will need to have a professional engineering license, which is a process similar to like a doctor or a lawyer where you get your degree, you take a test, you have some time where you're gaining experience, and then you take another test. And basically that just says that you're minimally qualified to be an engineer in the state that you're practicing in.
I would like to add on kind of a combination of the last question too, is that like your education from high school and college is not everything you need to know to be a successful engineer. There's so much on the job training that happens, and there is continuous learning that happens. So I never stop learning. And when you get to a management level, you're going to continue to learn how to be a great manager too. So that process of like learning, it starts, you know, in elementary school and everything, and you are just proving that you can continue to learn the material. It is not like getting a college degree and that's the last time you're gonna learn. It's just providing a foundation for what you're gonna be learning in your career.
You guys have made some really good points. I'd like to throw in before we move off of this is that because I see some people asking about like hands-on things, which we'll get to in a second, but you even have engineering technology degrees. So one of the interesting things about the field of engineering is there's like a million different ways that you could go with this. How hands-on do you want to be, and where do you want to work, and what kind of personality you have, and how much of this is on the business side versus the technical side, and you know, there's everything from just certifications that people can get in work in engineering to 2-year degrees, to 4-year degrees, to masters and PhDs, and it just totally depends on the personality and the job that they want to go into. But Adam, why don't you follow up with the question that's actually from the audience?
Yeah, so one of the questions is there a lot of hands-on work in engineering?
I guess that's a tough one. If you're thinking hands-on, like building things. Oh, sorry, my lights just went off in my room. like building things or developing, prototypes and that kind of thing. I think mechanical engineers can have some hands-on work if you're working in like a fabrication plant or things like that. I do a lot of site visits where I get to see things, but I'm not building anything. I'm building models, or I'm building sets of plans to explain my design and to have a contractor build it. But I don't build things myself, if that's the question.
Yeah, that's where a contractor comes in and takes your design and puts it, on the site and builds it. So that there is that difference of what a contractor does and what an engineer does. And hands-on, like I would say we have models, we have design models that we build in design software on our computers. So we can tell how we have like 3D structural modeling capabilities, so we can see where the forces and the stresses go in a structural system. So as far as hands-on, that's kind of a tough question to answer. Everything's becoming more computer-oriented as far as design is concerned.
So what are the most essential skills that you need in order to be in engineering?
Basic understanding of math. For bridges, it's a big geometry task. So you need to know like sine and cosine and tangent and how to apply those. Bridges are rarely square. There's a lot of skews to them. Let's see. And then just like a physics perspective as to how things work, how forces work, how gravity works, how wind affects things, or ground motion like an earthquake would affect things. And just a passion for it too. I've been a TA. In college, I was a TA, and it was really hard to see engineering students who didn't want to be there, who were just there because their parents wanted them to go through the program. And so if you aren't passionate about it, you're doing this job every day of your life. And choose something that you want to do every day of your life. Now, have other hobbies. Like it'd be great to be an artist, but I'm not that great at art, or I want to be a dancer, but I'm not that great at dancing. But so like engineering, what was a good fit for me as far as my, a combination of my passion and my skills. So that, I'll let Bridget talk.
Yeah, I had thought like drive was my number one thing. You just have to be driven to learn new things every day. Because a lot of what Rachel's talking about, you don't learn day one of engineering school. You learn throughout engineering school and then also throughout your career. So your employer and your professors in school will give you tools, but as far as like skills you need to have to bring into it, you have to have drive. You have to be able and willing to communicate with people. And I think a good skill to have is you can be detail oriented, but you can also see the big picture.
Yeah.
So the next question we have in the chat, it says, my middle school students would like to know if your actual work is difficult, in quotes.
Oh yeah, it's difficult. It's challenging, but I didn't get into engineering because I thought it would be easy. I got into engineering because I thought it would keep me interested. I thought I would see new things and new challenges. learn more about myself and about the way the world works, and just get something new out of every day. And that is absolutely what I've experienced in my career.
Yeah, engineering is not easy. It is a process of solving problems on a daily basis. And those problems range greatly. Like right now, I'm looking at projects at the KCI airport that are like underground manhole structures, but require an aircraft loading on them. So that's not a standard for a typical underground structure, but yeah, definitely, like if you want to be challenged and solve problems on a daily basis, that's what it takes to be an engineer.
So never a dull moment.
Exactly. Sometimes there are dull moments, but sometimes it's like, whoa, I don't know how we're going to solve this problem. So there's highs and lows, definitely, but I think you'll get that in pretty much every career.
Agreed. So how did you decide to go into engineering, and what AP classes did you take in high school to jumpstart your college career?
I can start with that. I took AP Calculus, which was awesome. Really helped me not struggle through Calc 1 and Calc 2 in college. I feel like those were easier for me because I had that basis. I also took other college credit classes like psychology, and I'm trying to think, like world history, and all of those classes help make your course load easier and allow you to focus more on those engineering classes. If you want to graduate in 4 years and as an engineer, you're going to be taking 15 to 18 credit hours a semester, which is a pretty full course load. So anything that you can do to get some of those courses out of the way or make those courses easier, if you do have to take them in college, I think would really help.
I took AP Calculus as well. I didn't get the AP credit though. I decided to just retake Calc 1 and Calc 2 in college, which helped make that easier as I was working through my 18 credit hours of other coursework and architectural studios. And my senior year, I had kind of a light load in high school where I had the opportunity to take English 101 at JUCO, or a community college. So also think about that, getting actual college credit from a JUCO. And there's been a lot of talk about people spending the first year or two at a JUCO or a community college and getting some of that classwork out of the way before doing the last couple of years in engineering school. And just like I saw how KU was and how Purdue was, and Purdue is just on a different scale of engineering. Like there's a lot of opportunities in the grad school level that's important to consider. But as far as like your undergrad curriculum, every undergrad school who's known for engineering in every single state is a good choice.
So we have about 2 minutes left, and I know the last question I'm going to ask is a little bit of a loaded one, but if each of you can provide a very brief summary of what is a typical workday like.
Do you want to go first, Bridget? You want me to?
You can go first.
Okay. All right. A typical day. There are some meetings. I would say like 1 hour meeting a day just to coordinate with several people on a project. And then a lot of work at your desk. People are coming to ask me questions. I go ask my boss a lot of questions too. So definitely a lot of calculations and a lot of checking. Is that a good summary?
Yeah, that was great. I would echo some of that. So I spend most of my days at my desk, especially now that we're dealing with a pandemic. Not as much going out in the field, not as much going to visit clients for client meetings, but I do a lot of drafting. So using like AutoCAD, Civil 3D software to put together construction plans. Sometimes I'm writing reports, sometimes I'm doing studies. But a lot of the time I'm sitting at my desk and kind of doing my own thing until I need to ask someone a question or until I'm ready to start that quality control process where I say, okay, I'm done with my piece. Can you look at this and maybe outline, here's a few things that I'd really like you to look closely at. But some meetings, some coordination, lots of phone calls nowadays or Teams meetings like this to just check in and say, hey, did I understand what you were trying to say, right? And I had a question about this, can we talk this through? It's a lot of that, and that's one thing, just as a last note, I know we got to stop, but even though you're young, you can still add value to a project. Sometimes I might have a different perspective or ask a question that someone else hasn't thought of. And even though I don't have, 20 years of experience, I can still learn from that, even if it's a silly question, but sometimes it's not. And sometimes it's a question that my project manager says, that's a really good point. We need to give some more thought to that. And so even though you're young and don't have a lot of experience, you can add value to projects by asking questions.
That is a great final message to wrap up with.
Yes.
I mean, the idea that this is challenging and math is tough, but you just work at it and you get better and you ask questions and you're curious and you'll figure it out if you stick with it. If you're passionate about it, stick with it and good things will happen. So I want to say thank you so much for Bridget and Rachel for coming and talking to us today, and to our students in the audience for taking time to come listen to this. But we're out of time. In fact, we're over time. Thank you for sharing your passion, your insight. And I hope that you guys in the audience, I hope you figured out that this is we heard from 2 of 1,000 career opportunities that are related to this in the area. So if what you heard was interesting, but we're going to find out when you learn more about yourself that there are other opportunities that exist right here in Kansas City. We want you to grow up and be game changers and local business leaders so that one day you're here talking to future students, whenever you get older. So I hope you heard that message loud and clear. When I hit the end button here in just a second, you're going to get a survey link that pops up. It'll take you 1 or 2 minutes to fill out the survey. Please do that for us so that we get a chance to get better at what we do and to offer more opportunities like this in the future. This session will be recorded. We'll have it on our YouTube channel. You can go find it there if you want to rehear some of the information. And you can always go to the NEBA website, which is nebaworkskc.org. If you want to learn more about the Northland Education Business Alliance and what we're trying to do to help students find their career passions and their career paths moving forward. So thank you again to our speakers. Thank you, Bridget and Rachel. We appreciate you so much, and have a wonderful rest of your day.
Thank you.
Thank you.